Well, hey everyone, and welcome back to the next video in the Dungeon Generation tutorial series. In the last video, we were able to get tiles set up and our grid actually to display. I know it looks right now just like it's a bunch of darkness, as if it's just like one giant spray. But you're going to see as we start laying down the rooms, it's going to look a lot different. So, now that we got those tiles set up, let's go ahead and start creating our room. We'll go into here, we'll make a room. Open it up in Visual Studio. Because essentially the room is just the way we're going to group the tiles together. So now we got our room open up. Okay. So here we are. And then we'll come into here. So what is the room going to have? Well, the room is going to have public int x position, where it starts. It's going to have a public int y position. It's going to have a public int width, public int height. Okay. We're going to make a private integer for the top wall. And I'm going to explain to you in a minute what all of this is and why we're doing that. Private int, and then right wall. And then we'll have the size of the room all together. We're going to go ahead and make this. We're going to serialize this so we can actually see them in the inspector. So system now serializable. Okay, we can go ahead and get this. Alright, XY. Cool. So now next, what we're going to have is have a public int center x, which is the center of the room. It's x position, and then the center of the room, y position. Okay. Now we got that set up. Let's go ahead and make a constructor for it. Public room. This. I'm going to go ahead, and this is actually going to take some parameters. So it's going to have an x position, it's going to have a y position, it's going to have a width, and it's going to have a height. Out of here, going to have this dot x position going to be set to x. This dot y position going to be set to y. You guessed it. This dot width set to w, and then this dot height set to h. Okay. And then the size of the grid is the total size of the room, which is going to be this width times this height. Very simple. Now what we want to do is we want to figure out the top wall. Well, the top wall is going to be from the y position, adding the height of the room, there it is. Okay, so basically, like, let's say your y position is at 0, and you have a height of 10. Like it's a room size 10 high. So you would take that 10, add it to the y position, you would get 10, and then you would subtract 1 from it. The reason we're doing this is because in the way it works with grids and such is, you know how it's never just 1 through 10. it's actually 0 through 9. When we're talking about indexes, we're talking 0. If you have a size of 10, it'll actually be indexed from 0 to 9. Like if you have a list of 10 objects, you index it from 0 all the way to 9. So what this is going to do is say, okay, well, if my position is at 0 and I have a height of 10 tiles, I'm 10 tiles tall, I need to add those together and I get 10. I need a -1. So 9. So my top wall is going to be at 9. And that's what we're looking for. So it's going to be the same thing for the right wall. But the difference here is it'll be this dot x position plus this dot width. And then that'll be -1 as well. And then we're going to calculate this dot center x is set to this dot width divided by 2. And then this dot center y equals this dot height, wrong one, divided by 2. Like that. There you go. So if you have a width of 10 and a height of 10, you divide by 2 on each, that's 5. So the center x is going to be 5, the center y is going to be 5. So the tile in the center of that room will have coordinates of x and 5 and 5. That's essentially how that's going to work. It's just basically, where am I at in regards to this room? In regards to this room, I have a room width of 10 and a height of 10. So I'm going to be at 5x 5y. I'm the tile that's in the middle of this specific room. That's basically what this does. Okay. And then we got that set up. It should be good to go for now. Let's go back over to our grid behavior. Now that we got the tiles set up, what we need to do now is create rooms. So what we're going to do first of all is we're going to go and create a list of rooms. So we'll come back up here. We got our dictionary, we got our grid size, and after the grid size, we'll come back here, and then we'll have a public list of rooms, and we'll call them room list. After we set up the tiles, we know we got a blank canvas to work with. Then we can go ahead and create the rooms. So what we'll do here is we'll initialize this dot room list to a new list of rooms. New list of rooms. And then we're going to come in here, and let's say we're going to have a public variable. We can make a private variable. Goodness. I'm trying to use the mouse and then my hand off. I was on the key touchpad. Okay, so we'll have a private variable. Int max room count. This is how many rooms I want to draw in this grid at the most. And we're going to set it to 10. The most rooms you can have on this dungeon floor is 10. And then we'll serialize the fields so we can actually change that in the inspector if we wish. Now we're going to come into here, and we're going to for int I is less than max room count. So it'll be all the way from 0 to 10. And then what do we want to do in here? What we want to do in here is we actually want to create the room. So we're going to come into here, and we're going to go private void create room. Or as a matter of fact, you can just do create rooms. Come into here. We'll take this and we'll actually bring it into this function here. And this will just generate it. And then inside of here, we'll just say dot create rooms. like this. So we'll do this. So we're going to loop through this number here, and then inside of here is where we're going to actually start creating the room. So how do we create the room? Well, basically what we're going to do is we're going to randomize some numbers. So let's get started with the int room x is set to random.range. And we're going to say I want the index to be at least 1 because 0 is going to be set for like a boundary around the x and the y on the bottom wall and the left wall of the entire dungeon itself. So we don't want them to put anything on 0, just that. Now, because we did a grid of 111 by 111, I'm going to set this number to 101. When you do random.range, it excludes the number at the end. It does 1 before it. So this is going to randomize a number between 1 and 100. So we're going to do that. We also want to do the same thing. This would be for the x position. We also want to do the same thing for the y position. Okay. For the y position. So now we have that. It's going to generate a number there. Now, this dot rows, and what we had up there is going to be set to, we can do copy paste, and then we can, because we're going to set a random number for the rows. How many rows do we want for this room? I want the minimum to be 5, and I don't want there to be more than 10 rows. There should be no, that's a huge room. And then we'll do columns is set to random, set to the same thing, and then we'll set that one to 10. Now it starts to make sense as to why we did 111 by 111 earlier. Because this 111, okay, if we draw, what's the biggest size room we can have? A room that is 10 rows by 10 columns. That's the biggest room you can have. Well, where's the highest, where's the most, let's see, what is the highest place you can put a room? It's going to be 100x and 100y. So if you have a room that starts at x position 100 and y position 100, and then you add its size to it, which is the biggest 10 by 10. If you add 10 to the x, you get 110. If you add 10 to the y, you get 110. So that means the furthest room you can fit in here is at x position and y position 100 by 100, and it can be a 10 by 10 room. So that means at the very top it's going to end at 110, 110, which is actually one tile less than its x and y position here. So that means in the top of the grid and the right side of the grid will always have one tile strictly for a y. Strictly for a wall, excuse me. So this is how we set our boundary to say, hey, your boundaries are going to be set between 111. Your rooms are 10 by 10 at the biggest. You cannot go anything beyond 100, because if you put a position that's greater than 100 and you give it a 10 by 10 room, it's going to go outside of the entire dungeon floor, and that's not what we want. So this is to constrain it. Okay, now we got that set up. Okay. And then inside of here, we're actually going to go, so now we got all that generated. We need to go ahead and actually like create a room. So room, set to a new room. And it's going to have room X. Oop, too fast. Room X, room Y. And it's going to have this dot rows. And this dot Y, columns. Like this. Like this. Okay. And then it doesn't have to be up. Like these rows and columns, you don't have to go and put them here, but it caches it. So because I put rows and columns here, it only creates this variable once for each, and then it overwrites them here. We could do the same thing for room X and room Y if you want. You can put private room X, private room Y, and then you come into here and say this dot room X, this dot room Y is set to this. Because this right here, every time you call create rooms, it's just going to go and cache this. But because we got the loop outside, we can actually do that. I just want to let you all know. See, now we can take this out. There's no reason for it. And then we can do int rows and then int columns. And it's very simple. So this way. Now, this is how everything is going to be generated and set up. So what we're going to do now is we're just going to, for each one, we're going to go ahead and draw the room. So in create rooms, and we're going to do this, by the way, not just once. So inside of create rooms, we're going to loop through this max count list. Now we're going to do this. So for every room, we got to every iteration of this loop, we got to randomize the room X, room Y, the rows, the columns, and we're going to create another room. Now inside of here, we're going to do some things. So what we're going to do is we're going to this dot room list dot add, and we're going to add R to it. Wall room. We're going to go and add it to the room list. Create a variable called walkable false. Okay. And then we're going to create a game object. Game object. And okay, geo game object, and we're going to set it to a new game object with room. This is just to create like the visual of where it is in the hierarchy. That's all it is. This, and then we'll do .g.transform .position is set to vector 3.0. Man, you think it would just autocorrect really quick, but it doesn't. So okay, well, no big deal. So vector 3.0. Okay, now inside of this, we need to do two more loops. For I is this, I is less than the width of the room. And inside of here, we're going to do another for loop. And we need to do J. And we need to do room.height. So we're going to loop through the size of the room and say, hey, if oh, okay. Yeah, we can do that. Okay, so that's why. Well, you know what? Instead of complicating this, let's do this. Take this out and do it a different way. Paste it here. And then up here, we're just going to say this. Or int I is less than room count. Just to get some clarity. No, come on. Like this. We'll just do this. Create rooms. There. So for each room in there, we're going to create a room. Okay, we'll just create room. And inside of here, we're going to do away with this. So we can take this out, and all this. And we can take all this and just shift it over, shift tab to bring it over, make it look pretty. And we'll hold this off for a second, bring this back. We're gonna formulate this better, like this. Okay, so for each count in there, we're gonna go ahead and create the room. How do we create the room? We're gonna randomize it. Come down here, cache a variable for false, create a new instance for it up there. We're gonna go through the width, through the height. Now we're gonna say, hey, if I is equal to 0, or j is equal to 0, or I is equal to r dot width, excuse me, room dot width minus 1, or room dot height. Wow. Room dot height minus 1, or I is equal. J is equal. Then we'll do walkable. Just set to false. Because what we're saying is like, hey, if the current index, if your current x is 0 or your current y is 0, you're at an edge of the room. That's not walkable. You're making borders around your room. If your width is 10 minus 1, if you've hit a wall on the x-axis, or if it's you hit the ceiling and the roof of the room, then you're gonna set the walkable to false there. Else, walkable is set to true, which means it can be walked on. Okay, so we'll come in here. One last thing. What we're gonna do is we're gonna go into here and say, gonna cache a tile. T is set to this dot tiles at index of I plus the room's X position and J plus the room's Y position. Okay, room, not rooms. So basically, we want to go into the 2D array and say, hey, I want you to grab the tile from where the current index is plus from where the room is, and you're gonna get that, and you're gonna cache that. So now we have a tile. Now all we're gonna do is say t dot is walkable is set to walkable. Okay, so now it's walkable. It's either true or false. If t is walkable now, then we're gonna go this dot tile to visual at key of tile dot get component sprite renderer and then set the sprite to this dot floor, the floor sprite, and then we're going to take it tile to visual t dot transform dot set the parent. I said dot. Whoa. Transform dot transform dot set parent as go dot transform. Alright, so let's walk through again what's going on here. So we randomize the number between 1 and 100 for the room X, for the room Y. We want to generate a room that has 5 to 10 rows in it. Well, that's true. This needs to be 11. Excuse me. Now, this is going to be a generator number between 5 and 10 because it doesn't include the last number. It goes right before it. So 5 and 10 rows, 5 and 10 columns. We're going to create a new room. We're going to add it to the room list. We're going to say, hey, we're going to grab a boolean, make it false. We're going to create an empty game object, set its position to 0, called room. This is just for clarity in the hierarchy. So we're going to loop through the width and the height of the room, and we're going to say, hey, if I is equal to 0 or j is equal to 0, that means if it's anywhere along the left side of the wall, or if it's at the very bottom, if it's at the very bottom of the room like this, we want them to be walls. If it's the very left side, it's a wall. This right here says if I is equal to the room.width minus 1, that means if it's the right wall, and then j equals the room height minus 1, says, hey, is it the roof? So if it's any tile that falls on the left wall, bottom wall, right wall, or the ceiling, we need to set it to false. You can't walk there. Anything else, you set it to true. Come right here. We're going to find this tile that is in the 2D array that we have. And we're going to go and cache a variable. We're going to say, hey, is walkable, set it to walkable, whatever it's going to be. If it is walkable, go into the dictionary, grab its game object, set its sprite to floor, and then come into here, and then set the parent to the room here. This is just to clarify what it's in hierarchy to make it much more manageable. So now that that's done, when we hit start, it's going to go and create the rooms. So over here, we're going to create 10 rooms. This is the room list. It's empty, but it's going to be generated when we hit play. Bam. So you can see here, you can't really see it here because we're not moving the camera or anything, but you can see in here, it created rooms. All of these are black tiles. This is a room. This is a room. All of these are rooms. How many rooms it created? 10. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's doing what we want. However, I don't want it to intersect like this. So in the next video, we're going to write some code that stops rooms from actually intersecting like that. We'll go ahead and take care of that in the next video. But for now, we got the rooms, we got the tiles. Look pretty good. So I will see you guys in the next video. Thanks for sticking around. Later.